Okay, so this is continuing on from the last one where we found out that new substances are made, reactants are changed into products, and we learned that there should be the same number of atoms of each type of element on each side of a chemical equation. And remember, the small numbers are very important because they tell you the formula of a particular compound. And we don't change the small numbers, we just change the big numbers. So here, if we were trying to show that we had 2 molecules of carbon dioxide, we put a large 2 in front of the CO2 to show that there are 2 molecules. And we went through a process of counting up how many atoms there were of each element on each side of the equation and changing the coefficients or the big numbers to try and balance the equation. And I left you with this set of problems here. First of all, we've got carbon reacting with oxygen, so carbon burning in air to make carbon dioxide. So let's go through and check. We have carbon here, we have 1 atom of carbon. Look on the other side, 1 carbon. Okay, that's okay. What about the oxygen? We've got 2 oxygens, and here we've got 2 oxygens. Okay, so that's alright, that's balanced. We don't have to do anything to this equation. What about here? Well, starting off looking at the hydrogens, we've got 2 hydrogens here, and we've got 2 hydrogens here. Fantastic. Oxygen, we've got 2 oxygens here. Here we've only got 1 oxygen. So what can we do? Well, we can't put a 2 here. That's the one thing we can't do. We can't change the formula. That would give us a different compound entirely. So what can we do? We can put a big 2, a coefficient of 2 in front of the H2O. That means that we've now got 2 oxygens on this side of the equation. Brilliant. So let's go through. 2 oxygens here, 2 oxygens here. Oxygens are balanced. Right, hydrogens. We've got 2 hydrogens here, and oh dear, we started off with 2 hydrogens here, but now we've stuck a large 2 in front of it. We've got a coefficient of 2. We have doubled those hydrogens by 2 as well. So whereas we had 2 before, we've now got 4 hydrogens on this side. 4 hydrogens on this side, 2 on the other. So we need to put another 2 on this side. Let's go through. 2 times 2, 4 hydrogens. 2 times 2, 4 hydrogens. 2 oxygens, 2 oxygens. Our equation is balanced. Okay, let's look at number 3. So, starting here, we've got 2 nitrogens on this side, and we've got 1 nitrogen on this side. So okay, before we do anything else, we've got to try and do something about that. Let's put a 2 in front of the NH3. So let's look again. We've now got 2 nitrogens on this side, and we've got 2 nitrogens on this side. Fantastic. What about the hydrogens? We've got 2 hydrogens on this side. We've actually got 3 hydrogens in the formula, and because we've got a 2 here, we've got 6 hydrogens altogether. So what can we do? We've got 2 nitrogens on this side, 2 nitrogens on this side, we've got 6 hydrogens on this side, we've got 2 on this side. So we're going to have to change that. We want 6 hydrogens on this side. We've got 2 there already. How are we going to make it into 6? We'll put a 3 in front. Now go through the process. Go through each one in turn. 2 nitrogens, 2 nitrogens. 3 times 2, 6 hydrogens. 2 times 3, 6 hydrogens. Our equation is balanced. And our final one. Let's go through one by one. We've got 1 carbon here, which is methane burning in oxygen to make carbon dioxide and water. 1 carbon atom on this side, 1 carbon atom on this side. Fine. Well, here we've got 4 hydrogens. Let's look on the other side. We've only got 2 hydrogens on this side. So what can we do? Well, let's try putting a 2 in front of here. So now we've got 2 times 2, we've got 4 hydrogens on this side. Okay, start again. 1 carbon, 1 carbon. 4 hydrogens, 4 hydrogens. 2 oxygens, 2 oxygens. And another 2 oxygens here. We've got 4 oxygens altogether. So here we are, we need to put a big 2 in front of the oxygens on this side. Now let's go through the equation, count them up. Do this as many times as you need to. 1 carbon on this side, 1 carbon on this side. 4 hydrogens on this side. 2 times 2, 4 hydrogens on this side. 2 times 2, 4 oxygens on this side. 2 and 2 is 4 oxygens on this side. Our equation is balanced.